So, what's the story on Mars? Mars is, in a way, it's the most interesting of the terrestrial objects. I mean, other than the Earth. The Earth is an interesting place. But what about Mars? What's the story on Mars? Why is Mars so interesting? Why is Mars so cool, so fun, so, well, okay, you go back, in history 100 years ago, and you'll find science fiction stories written about going to all sorts of worlds. But then once the space age begins, things get, and it's, all these science fiction stories, there's people living in aliens and all sorts of things in all these sorts of places. But Mars is the place where we think, there might be a chance. We might be able to find life or traces of life or stuff like that. Venus, not a chance. It's hot enough on the surface to melt Venus to melt lead. Mercury is as barren and lifeless as the moon. Mars is interesting. So Mars has abilities of life, either maybe today, maybe in the past, maybe in the past, so let's first of all think about it. Okay, if I'm interested in living organisms, then what are living organisms? Living organisms are, bags of water, basically. That's what I am. I'm an ugly bag of mostly water. No, I'm actually rather good looking. No, but the key point is that my body is like 60% water, and so it is the same thing for every living organism on the face of the earth. Whether you're talking about a tree or a bacteria or a whale or I don't care what, water, liquid water, is a huge constituent part of what life is. And that's a rare thing. You start looking around the universe and forget about it. There's the other ingredients of life. I have a lot of carbon's everywhere. I have all the, I need energy's everywhere. These are common things. Water is the hard thing. And so the reason why we're interested in possibilities of life is possibility of liquid water. Liquid water, good old-fashioned H2O. Now here's the interesting thing about liquid water. Water cannot exist. It is impossible for water to exist out in the vacuum of space. We'll never look out and point out a telescope and see a big blob of water floating around in space. Water requires pressure of an atmosphere. Right now, right here, with the weight of all this 100 miles of air between me and space, puts a lot of pressure on me. Right now, there are 15 pounds of pressure on every square inch of everything down here, and that's what holds the water together. If you were to take a thermos full of water out into space, open it up, then you know what would happen? It would mostly boil away. Even though the temperature is still the same, it's 70 degrees or I don't know, whatever it is here. You unscrew that, and at the pressure down there, the boiling point and the freezing point of water come together, and so basically you'd open it up and the water would just boil away, and then there'd be a little bit of frost left over. Up in the vacuum of space, with very low pressure, water and all other liquids must be in either solid form or gas form. To have liquid form requires pressure of an atmosphere, and right now Mars's atmosphere is 2% as thick as us, and so therefore it is impossible for liquid water to exist on the surface of Mars today. Impossible for liquid. You can have the frozen stuff, you can have the gas stuff, but for liquid water to exist on the surface of Mars, on Mars' surface today. Some people have wondered, well, what about underground? Underground, then you have the ground on top of you, so that you may have another source of pressure. So people are wondering about that. And then, of course, there's a certain range of temperatures. Mars is cold. Mars is a frozen desert. It's colder than Antarctica. It is a very, very cold place. So not only do you not have the pressure, but it's also fantastically cold. So any water you would have would be in solid form, and then if sunlight could turn it into vapor form. Living organisms, every living organism ever found, which are all here on Earth, has substantial amounts of liquid water. That's the medium that lets the machinery, the molecular machinery of a cell to function. So forget about it. Life could not exist on Mars. And then we start looking at the surface of Mars. And when we start looking at the surface of Mars, we can see clear erosional features. And that's what's interesting. Features, not just wind erosion, because we see that too. And there's dust storms on Mars. There's all sorts of stuff like that. But we see erosional features, erosion of liquid water features on Mars. We see features that are dry riverbeds, dry lake beds, dry river delta. They're dry today. There can't be any liquid water on Mars today, but there's clear evidence. You can even see places where you get, these little channels and streams coming together to form bigger sorts of channels, and it makes you wonder, well, golly, when we have that here on Earth, we've got this crazy little process we like to call rain. So I wonder if this rain might have existed on Mars. It's really, really interesting. And so we look at now on the other hand, most of these erosional features that we're talking about, dry riverbeds, dry lake beds, dried river deltas, these sorts of things, they also occur in regions where you have lots of craters. In regions with lots of craters. So what does that mean? Craters are our clock. Craters are what happened to a surface when nothing happens to a surface. When a surface just sits there and there's no volcanoes and then there's no erosion and there's no continental drift and there's nothing weird going on and it just sits there, then, rocks from space hit it every now and then. And so we can use that as kind of a rough clock. If you see, you get a 100 mile by 100 mile area, you start counting the craters. The more craters you are, the older it is. We can kind of calibrate this based on rocks from the moon. We've brought back rocks from different parts of the moon, younger regions where there were some lava flows 3 billion years ago, 4 billion years ago. And so we can date the rocks and we know, okay, this means this is a number of craters. And it might be different in different parts of the solar system, but Mars is in our neck of the woods. So we can date this pretty well. So we can tell that these, regions with lots of craters, that means these regions are very old. And basically we're talking about there was substantial erosion, water erosion, liquid flowing water erosion on Mars about, 4 billion years ago. A billion years ago. And that's interesting because that's when life formed on Earth. When life formed on Earth, life formed here in our oceans 4 billion years ago. I mean, basically the oldest rocks we have here on Earth, the very, very oldest rocks anywhere you find here on Earth are about 4 billion years old. That's about the oldest we can get them, dating them radioactively and stuff like that. And when we look at those, the ones we find that, these are the sorts of minerals that form at the bottom of oceans. And then you study that, and there's subtle, but there's real evidence in those that you've got one-celled organisms. Very, very, very simple life going on there. So life formed on Earth about 4 billion years ago. And at the same time life formed on Earth, there was not life, but there was water. There was liquid water on Mars. Maybe not oceans. Oceans are a big deal. We have oceans here, maybe ponds, pools, seas, Great Lakes, sort of thing like that. Certainly it's very hard to tell because it's certain regions of the crust. There are other regions of the crust which are younger, covered over by lava flows, and then where you don't have as many craters, and then you don't see as much erosion there. So erosion existed on Mars for a certain period of time. As we mentioned, okay, why did this happen? Well, Mars is smaller. It's about half the diameter of the Earth. So initially it forms, it has volcanoes erupt, the volcanoes supply an atmosphere, so it has an atmosphere, not nearly as thick as the Earth's, but apparently just barely thick enough to allow you to have enough pressure to have some liquid water on the surface. And then this exists for a while, roughly, a billion years. Everything, the whole solar system formed 4.5 billion years ago, so maybe somewhere between 4.5 and 3.5 billion years ago, you have lots of active volcanism on Mars, volcanoes erupting, lots of gas, lots of atmosphere, then the interior cools. It kind of more or less starts to become more and more solid to the point where you don't have significant volcanic eruptions anymore. Once you don't have significant volcanic eruptions anymore, then the atmosphere gradually leaks away through several processes. First of all, there's no lid on the atmosphere. All atmospheres are constantly leaking away into space. The hotter the atmosphere is, the faster it leaks away into space. So that's constantly going on. You also have, like we talked about with the Earth, liquid water dissolves carbon dioxide. So that's a major constituent. When you talk about the gases that volcanoes put out, carbon dioxide is huge. That is a major, major, major thing. And so then that starts, so if Mars did have seas, that could have pulled in its carbon dioxide. Certain amounts of it just became frozen. Simple enough. As the atmosphere goes away, it gets colder. The atmosphere acts like a blanket to keep a planet warm, so then it freezes. Right now, Mars has polar ice caps. It has a northern polar ice cap, a southern polar ice cap. These, it has seasons. These wax and wane with the seasons. And so these get bigger and smaller. And these polar ice caps are made of two things. There's frozen water, real frozen ice, H2O. There's also frozen carbon dioxide, dry ice, which you got to be really cold in order to do that, but that exists there as well. So a certain amount of that is frozen. There's also a certain amount which is permafrost. Underneath the ground is frozen. So that's another interesting thing. In order to search for life on Mars, the first attempt to search for life on Mars for Sirius with the Viking probes They landed on Mars back in the 1970s. And they scooped up little bits of soil, and you put the little bits of soil inside, and then you add some water, and you cook it up, and then you see what happened. And at first, everybody was all freaked out because they started getting all sorts of crazy reactions. It took some serious analysis to figure out what was going on. It turns out, nobody really realized this, Mars has no ozone layer. So Mars has, so they definitely got reactions, but the reactions are not from life. Basically, what happens is, since there's no ozone layer, the sun's ultraviolet light comes down and sterilizes the first few inches of the Martian soil, the Martian regolith, the sandy, dusty stuff that makes up the Martian surface, and does all kinds of crazy chemistry. It creates what the chemists call a very oxidizing environment, basically because you got all this ultraviolet radiation coming down, tearing all these molecules apart, doing all this kind of crazy stuff. So basically, it's very reactive, especially when you add water and kind of react things up. So they got a reaction, but it was non-biological. They were hoping maybe there's stuff in the soil. Forget about it. Solar UV sterilizes and then creates nasty chemicals in the top few inches, at least, maybe top 6 inches, top few inches of the Martian soil. And that, it's just so fantastically reactive. No living cell could survive in that. So, and then plus you got dust storms and stuff, so it moves around. So this I don't know, the top foot of the Martian material, forget it. Not a chance of life. Both the radiation and then all the crazy chemicals created by the radiation would just wipe it out. So that's not possible. So what are we talking these days? We're talking fossils. Things from the past. So we've got our rovers and stuff we send to Mars, look around for this. They have found clear evidence of minerals that indicate there was liquid water in the past. So no doubt about that now. And then, so underground, permafrost sort of thing. So people are talking about that now. That's really interesting. If you go down, 6 feet under the soil. Here's the deal. Living organisms on Earth fill everything. There is no place on Earth, nowhere you can go, where every crevice isn't filled with some kind of crazy little bacteria. You go to the driest, you go to Death Valley, the driest desert, you sample the soil, you will find crazy little one-celled organism cells that have learned how to survive there. You go to Antarctica and you can find these barren wastelands, sort of things like that. You dig up, oh yeah, there's bacteria there. You can drill miles underneath the surface of the Earth. You bring up rocks which have been locked under the surface of the Earth for millions, billions of years. You bring them up, you study those rocks, and what do you find? You find happy little bacteria, endoliths, these little bacteria that have evolved to survive in the crevices in the rock. If life existed on Mars, if life formed on Mars in the past and was anything like life here on Earth, I would expect it to diversify and those one-celled organisms to fill every crevice of everywhere on Mars that they could possibly survive. And shoot, if you're 2 miles under the surface, how do you know whether you're on Mars or on the Earth? That's the kind of thing. If you go 6 miles under, it's not 6 miles, 6 feet under the surface of Mars, there's enough weight of that soil there that you can have traces of liquid water. So is there something there? We know there's permafrost, some kind of frozen things. Go to the Arctic and there are things that kind of live on the semi-melted frozen edges of the permafrost. That's interesting. That's the sort of thing that we want to do, that kind of get there, dig down, get into the permafrost. Are there any warm spots, maybe any volcanic sorts of places that are, okay, well there are no active volcanic eruptions, but are there slightly warm areas where you have semi-melted stuff down there? If life formed on Mars and was anything at all like on Earth, then I might expect there to be tiny little one-celled organisms down there somewhere that we could find, and then that would be really, really interesting. So that's kind of why Mars is a really interesting and exciting place to study today.